Bearings support the shafts in all kinds of machinery. This enables the shafts to rotate smoothly. How are bearings made and used? Let's learn together. In ancient Egypt and Mesopotamia, it is said that logs were placed under heavy stones to transport them. This ancient wisdom is said to be the origin of bearings. By arranging logs in a circle, you can see a structure similar to that of modern bearings. The invention of bearings, which reduce friction and move objects efficiently with minimal force, has greatly advanced human civilization. Today, bearings are used in a wide variety of applications, from vehicles such as rolling stock, automobiles, and airplanes, to household appliances such as dishwashers and vacuum cleaners, industrial robots and wind turbines, and even rockets and satellites. So, how are bearings structured? Bearings are broadly divided into 4 basic components. The outermost ring is the outer ring, and the innermost ring is the inner ring. Between these rings are the rolling elements that rotate. A cage keeps the rolling elements in place at equal intervals. In addition, bearings are classified as ball bearings that use balls as rolling elements and roller bearings that use rollers as rolling elements based on their application. Next, let's see the manufacturing process for bearings. Bearings support the smooth rotation of all kinds of machinery. Although bearings appear to have a simple structure, advanced technology is required to manufacture them. Let's learn about the manufacturing process for ball bearings, the most common type of bearing. Let's start by looking at the overall process. The outer ring and inner ring are manufactured through the processes of forging, turning, heat treatment, grinding, and raceway superfinishing. The balls used are mainly steel balls, which are manufactured through the processes of cold heading, flashing, heat treatment, grinding, and lapping. The cage is manufactured through the processes of punching, wave pressing, finish pressing, and rivet hole punching. The bearings are then completed with assembling, washing, inspecting, and rust prevention. Let's take a closer look at each process. The first step in manufacturing the outer and inner rings is forging. First, a steel bar is heated to make it easier to form. After the steel is sufficiently heated, it is inserted into a press machine. It is then cut to the specified length to form a cylindrical billet. Inside the press machine, outer and inner rings are made from a single billet. First, through 1, preforming, and 2, finish forming, the billet is formed so that it can be easily separated into an outer and inner ring. Next, the outer and inner rings are separated in 3, and the inner ring is punched out in 4. Now, let's take a look at the actual video. The billet is transported from the left side of the screen, and you can see that it is formed in 4 steps. This completes the forging process. The next step is called turning. The forged outer and inner rings are turned to cut a rough shape. The outer ring is rotated while being turned with a specialized tool. First, the face is turned. Next, the chamfer, inner diameter, raceway, and outer diameter are turned. Next is the inner ring. It is turned in the same way as the outer ring. This completes the turning process. The outer and inner rings that have finished turning are not yet sufficiently hard. Therefore, they are subjected to heat treatment to make them hard and durable. The outer and inner rings are transported into a heat treatment furnace and heated to over 800 degrees Celsius. This high temperature is maintained for a certain period of time to ensure the material is heated uniformly. The heated outer and inner rings are then quickly cooled in oil. This process is called quenching. The metal structure of the material transforms, resulting in increased hardness and wear resistance. Next, a tempering process is performed by reheating the material to approximately 180 degrees Celsius. This gives the bearing the necessary toughness and dimensional stability. This completes the heat treatment process. Next is grinding. In grinding, dimensions are ground to the accuracy of 1 micrometer or 1/1000th of a millimeter. First, let's go over the outer ring grinding process. The first step is face grinding. The outer ring is passed through 2 rotating grinding wheels to grind both faces. The next step is outer diameter grinding. The outer ring is passed through the grinding wheel and the regulating wheel to grind the outer diameter. Next is raceway grinding. The outer ring is ground using a grinding wheel shaped to match the raceway of the outer ring. Next, let's go over the inner ring grinding process. Like the outer ring, the face is ground first, followed by the raceway, and then the inner diameter. Once grinding is complete, it's time to super finish the raceway. Raceway are polished with a super finishing stone to achieve a smooth surface. First, the outer ring. The super finishing stone is oscillated to polish the surface. Next, the inner ring. The inner ring is polished like the outer ring. Look at the shine of super finished raceway. This process achieves smooth rotation with minimal noise and vibration, even when used at high speeds. This completes the outer and inner rings. Now that the outer and inner rings are complete, let's move on to the steel ball manufacturing process. First is cold heading. Steel balls are made from bearing steel wire material. In the cold heading machine, the wire is cold drawn and then cut to a fixed length. In the cold heading process, the wire is fed into a die to form a sphere. At this stage of the cold heading process, the excess material, or flash, that looks like Saturn's rings and 2 navels is left on steel balls. Next is flashing. Here, the flash left from the cold heading process is removed. Steel balls are placed between 2 cast iron plates with grooves. Pressure is applied and the balls are ground while being rolled. Flashing is not completed in one step. Steel balls are sent back to the cast iron plates by an automatic feeding device. This process is repeated multiple times, gradually removing the flash from the surface until the balls take on a round shape. Look at this steel ball after flashing. You can see that the flash has been completely removed. Next is heat treatment. Like the outer and inner rings, steel balls are also heat treated to make them hard and durable. The process is the same as for the outer and inner rings. After the steel balls are heated, they are quickly cooled in oil as part of the quenching process. Next, tempering is performed. The heat treatment of quenching and tempering results in steel balls with both hardness and toughness. The final stage of steel ball manufacturing is grinding and lapping. In grinding and lapping, grinding plates are combined in the same way as in the flashing process. Steel balls pass through the grinding plates multiple times, undergoing rough grinding and finish grinding. During this process, the steel balls become rounder and their surfaces smoother. Finally, lapping is performed using finishing grinding wheels, polishing the surface of the steel balls until they're like mirrors. This results in the roundest ball that can be produced by human hands. Finally, any remaining oil or fine metal particles on the surface are removed by washing. The steel balls, which have been polished multiple times throughout the process, gain even more luster. This completes the steel balls. Let's now look at the manufacturing process of cages. General cages used in ball bearings are manufactured as follows. First, steel plates are punched into round shapes. Next, they are pressed into a wave shape that can hold balls. These are then pressed further in the finish pressing to achieve a hemispherical shape. Finally, rivet holes for assembly are punched out and surface treatment is performed to complete the cages. Now that all the parts are ready, it's time to assemble them. The outer ring, inner ring, steel balls, and cage are assembled to form the bearing. The outer and inner rings are brought to the assembly area. The raceway of each ring are matched so that their diameters are optimally combined. Next, the inner ring is positioned so that it contacts the outer ring. After ensuring there is enough space for the steel balls, the required number of steel balls are then inserted. Steel balls are then placed at equal intervals. The cage is attached from the top and bottom, and the rivets are pressed to complete the assembly. After assembly, the bearings are washed, inspected, and rust prevention is performed. This completes the bearing. Finally, each NTN bearing is carefully packaged and shipped to the customer. How was it? There are many processes involved in making a single bearing. All of them require a high level of manufacturing technology. NTN bearings manufactured through this process continue to support industry and daily life around the world.